Good morning, everyone. Welcome to the Time Series Analysis on Digital Hub webinar. Let's start off the event by mentioning some housekeeping tips. Please utilize the Q&A section to ask your questions. We will answer the questions during the webinar if the time allows. And for further discussions, I encourage you to join our community, the webinar Q&A group on the community at digitalhub.io. Please also notice our legal disclaimer. Material presented here, including text, images, codes, are subject to Digital Hub terms and conditions and are for demonstration purposes only, and may include future products and features and plans. Sharing, copying, reproducing, and modifying them in any form requires Integra's permission. I'm going to introduce today's presenters. Myself, I'm Hoda Rezai. I have Babak Shafi, Integra's founder and CEO, and Sylvia Lee with me. As part of this series, we will have 2 more events planned. We will have another one on March 9th regarding the time series forecasting on Digital Hub, and an event on March 30th on the data science best practices, which will be demonstrating on our platform, Digital Hub. I encourage you to join our platform. There's only 3 easiest steps to join the platform: subscribe to a plan and create your projects. To be able to access the notebook template that we are going to present today, you need to register and sign in through cloud.digitalhub.io and subscribe to a plan which best suits your needs and your team's needs. We have made the academia plan free for students, and we are also offering it to our event attendees for free using promo code UPHUB. Then you can create a project and access the notebooks. And with that, I'm going to hand it over to Babak for an overview of Digital Hub and Integra. To you, Babak.
Thank you, Huda, and good day, everyone. Thanks, everyone, for joining, either through the Eventbrite or LinkedIn or my invitation or Huda's invitation. We're excited to have you back here. If you don't know about Integra, I'll just spend a quick second. Integra was founded to focus on AI and ML services for oil and gas industry. We brought in our expertise, our platform, and a sense of community, being here based out of Calgary, to help our industry excel with using more and more technologies from artificial intelligence and machine learning capabilities. My background is in data and analytics, and I do believe in the power of what it can do for our industry. Therefore, my goal and everybody here at Integra is to get everybody else to believe in that and follow that and lead and leverage data and analytics, not necessarily just for us. We are a conduit, we are a catalyst, we are helping share expertise and knowledge and know-how, but by all means, try these things at home, at work, and see some of the use cases we have and some of the success that we had and replicate that. Our industry needs to change, our industry needs to improve and become more efficient. I'm a strong believer of data being one of those catalysts that will really can change oil and gas industry and make it a lot more efficient than it is. So hopefully this type of community work and knowledge sharing will help everyone down that path. Can we go next slide, please? Do have a few examples for you. It's not exhaustive. There's more examples on our website of where we have seen success with AI and ML. Drilling is an excellent area. If you are in drilling operations, make sure that you leverage big data to understand your drilling data set. It's an area, it's a toolkit, having access to these tools that can be benefit from these technologies. Well production optimization. Today we're going to actually look at an actual gas well and analyze the data. There are many different techniques you can use to analyze the data. You don't need to have sophisticated simulation softwares to do that, and we'll show you how you can do that on gas data. Pipeline and pump failures are another areas for really good use cases with machine learning, specifically pump failures, as well as doing the vibration analysis. I'm sure many of you are already doing this, and if you're not doing, these are really good areas that you could focus on and get great results. We have also had good results on in our upstream section with anomaly detections, filter channeling, and optimizing the water plants. Simulation is another technique. So aside from the AI and ML, using simulation and specifically Monte Carlo simulation in a big data environment will give you another edge. We have done these successfully. More than happy to demo specific these solutions. If you're interested, please reach out to myself, to Horam, through our website, through LinkedIn, or however means you wish to see the specific and the end results. Another one is optimizing the flow. So anything that has to do with data and flow, there's always room for optimization, especially in pipeline and midstream. There's lots of opportunities for optimization just using data and data science tools. And these are just a few examples of where you could leverage data science to exploit opportunities that exist in your existing data. Next slide, please. So one of the things that we did during COVID, because of the slowdown in a lot of what we did from a consulting and custom models, was to bring up a platform that we use internally to replicate these solutions to the public. We call it Digital Hub. It's a modern data science platform that gives data scientists, engineers, and subject matter experts a place to collaborate together on a cloud native concept, very cost effective, and it's scalable. We run into scalability and cost effectiveness issues as we were trying to deploy our solutions on our customers. Therefore, we build a solution, and we're happy now to share that with the rest of the community. And there is a free edition, so by all means, use it and provide feedback. It's early stages. It's been a few weeks that we have released it, but we're excited. Really good feedback so far from the community. So we really appreciate your support. Next slide. Who is it for? Like, who do we have in mind? There's lots of big data platforms and lots of cloud platforms that are generic, but we want to make Digital Hub be very specific to oil and gas. So we always say, made for oil and gas, but loved by other industries. It doesn't mean you can't use it in other industries. It's just that our focus has been on engineers and data scientists and business analysts. So we have created tools that allow a data scientist to collaborate with business analysts and engineers. In Digital Hub, the collection of tools that we have allow you to do business intelligence functions, so you can do drag and drop and visualize the data. You can develop data science, you develop machine learning, and you can work with engineers to collaborate across the board. And our target has been, as I said, individuals and small businesses. So if you have a small team, if you're a small consulting firm anywhere in the world, or you have a small team that is just starting out, or maybe you're a small organization, you have 1 or 2 data scientists, it's an excellent place for you to start and not to have to worry about all the technical configuration and capabilities that you need to stand up. And you can get up and running very quickly. We have pre-made notebooks, and we've tried our best to give our users everything we know up to this point that relates to data science and oil and gas. And of course, enterprises, if they're looking for customized solutions, we're happy to provide some of the core capabilities of Digital Hub on a customized platform. Next slide, please. Well, some of the features that we thought is important, obviously, was convenience, right? With the cloud platform, you can access it from anywhere. And we're cloud independent, and so we can be on any cloud at any time, and we integrate with any cloud. So if you already have data in Google Drive, or you have in your Amazon S Drive, or you have your blob storage in Azure, you can connect to all of these data and bring it in for processing and modeling. And really what we're focusing on in Digital Hub is development of the models, not where your data is. It's just really ability to develop the models and have some best practices. The scaling, using Kubernetes and Docker, ability to scale and make, your environment scalable. And the reason we wanted to be scalable was twofold. One was cost. Initially when you start early, you might have 10 different ideas that you want to execute on. And you don't need to have 10, full-blown servers to execute these programs. You can just go with smaller scale, cluster to execute your code. But as you grow and you need to scale, there should be seamless possibilities for you to scale up, and Digital Hub offers that. Teamwork was important, so you can invite team members. So if you're a team lead or a project lead or a business lead, you can have team members assigned to different projects, and different projects have their own cost structure and ability to charge accordingly. Big data was important to us. Like I said, we had use cases for drilling and drilling optimization. Being able to work with big data was important. So that's another feature that is coming up soon. And a central database. So that's another core component. We realized that a business intelligence tool, a data science tool, and different tools have different databases, but we created one database that connects all of them together. So any work that Sylvia does as a data scientist at the end of the day can be used in a BI tool by her as an engineer, on the other side. There's no duplication of the data. There's no duplication of the database. Security, everything is all integrated and incorporated into one slide. Next slide. We have some early pricing here. So like we said, free for students and webinar attendees. You just have to use the code in order to sign up. I encourage you to sign up today while you're looking at this. It's at cloud.digitalhub.io, and provide us with feedback. We'd really love to hear back from you and understand how we can make this thing better for individuals or freelancers. So if you're a freelancer or you're just trying things out, we have a plan. These are Canadian prices, by the way, at $14.99. That gives you the number of hours and the storage. And keep in mind that Digital Hub is based on hours and storage. That's how we've simplified the cost structure. For the small businesses, you have team capabilities. That means, one person can purchase a plan for $29.99, and they can invite up to 7 people to the same plan. So the resources from the same plan will be shared across 7 people. So this is a great feature of the Digital Hub, because with just $29.99, you can have 7 people enabled on the platform. And they don't have to have a subscription. They don't have to be a subscribed user. They just need to use an M&I ID in order to be authenticated with the platform. So great feature for a small business is that they're just trying to get their foot into the door. And the custom really, as some enterprises are asking us to implement it on their platforms, on their cloud, move it to a specific private cloud, and all those customization can be done, or a specific integration with historian databases. All of that, we combine a little bit of our consulting services and offer that to you. Thank you for that. But can we go to the next slide, please? All right, so I don't want to take a lot more time. This is really exciting. Hopefully, we are excited. When we look at the data and data science and what we can extract from it, we get very excited. This is from a gas well data. We're just going to look at generating some insight. Gas prices are going up, so hopefully there's some appetite in the market to analyze some of the historical data and make some improvement on the operations. What Sylvia is going to show you is some techniques that you can use to infer insight from your historical data, and potentially, understand the implications of the actions that you've taken in the past on your production. So with that, I'm going to pass it on to Sylvia. Thank you.
Hi, thank you, Babak. So to access the Digital Hub, you can go into cloud.digitalhub.io. And you will be able to just sign up here with our sign up link here. But in my case here, I'll just log in. So what you see in Digital Hub here is just the list of projects that I've already started for different sort of data science projects that I have on here. What I can show you is also how you can just very quickly create a project. So as Babak have mentioned, the way we built the Digital Hub is to facilitate so that it's starting a data science project is easy. And also getting the collaboration between your team members, we have also trying to make that more convenient to facilitate that. So in my case here, I'm just going to start a data science project. You will say I'm doing just a simple data exploration project. I go into my next step. I choose my different components. I'm just going to be dashboarding. So I want a business intelligence tool here. I'm using Jupyter as kind of my platform to do my data science exploration and my algorithm and modeling. Then I can add in different members. So then like I have a team subscription here. So as Babak said, I have can invite up to 7 members into my subscription. So in this case, I know for this project that I need to work with Hoda. So I'm just going to invite Hoda into this project here. I'm gonna give her owner access. And then maybe I'll also invite Babak into the project here. And also give him owner access. So the next, the final step that we could do to a project is to have a good title. And then a good description. Maybe I'll give a tag name. And simply create the project. So then like what this does is actually sending a command now to our backend to deploy all of these components for you. Because on Digital Hub, every single project is a single independent unit. So what's going to be doing in the backend is that it's going to build up a central database here that would link between my Jupyter Lab components and my superset, which is my BI components. So then all of the data within this project can stay isolated within just that one database that is centralized among all of your different applications. So just facilitating that data flow and removing some complexity out of it. So for the purpose of time here, and for this demo, we already have a project that's already developed that I'll be showcasing the use case on. So I'll be going to my Jupyter Lab and then show you the notebook and the analysis that we prepared. So while my Jupyter Lab launches, so this will be the notebook that we'll be showcasing on our data here. But one thing that is going to show you is you will be able to access the notebook if you already have a subscription with us and created a project. You can go into your Jupyter Lab components inside that project, go into the template section here on the launcher of your Jupyter, choose the Digital Hub template, and then go into time series processing. So this will give you access into this exact same notebook that I'm going to be showing you today. So just going into the notebook here. So as already mentioned, so we're doing a time series analysis on the gas well data here. So then what we're actually trying to say is that we have a sample gas well with some data generating out of it. So we have a flow data from it, and we also have some pressure data in terms of like the plunger and then how the gas well is flowing. We have 1 year worth of data, minutes frequency. So then like the whole problem domain that we have on here is that we know that there's a lot of very complex tools out there for generating insights off of your reservoir. But very oftentimes, like it's not very accessible for operators and so the data scientists onto these softwares, and it also requires a lot of technical skills and also very expensive to work with as well. But whereas the historical data that you have on your gas well, you can make that available. So then like this is the purpose of this demo here is to just introduce the concept of some time series analysis and skills that you can just apply to your data and generate some overall big picture insights out of it. So then everyone can like quickly identify patterns and then generate insights to use for them as a lens and then also into their day-to-day decision making. So the data set here is it's a sample data set from a sample gas well. We've altered it synthetically for this demonstration. So I'm just gonna quickly load up my libraries here. So I'm using a few libraries here from Python to work with time series, some common data science packages like NumPy and Pandas, also like SkyPy for my data analysis skills. So I'm just going to load up here my data set. So in here, we see that we have a data that is the casing pressure and also our line pressure measured in kilopascal, and then the flow of the gas well measured in Dex. So then the first thing that I'm going to come in and do is actually calculate my CLDP, which is the case line differential pressure. It's a very important metric that is often used in the operation of this plunger lift to do a lot of different analysis and also for operators to look at as well. So this is just simply minusing the line pressure from the casing pressure. So the next is starting off any data science project. I'm going to go in and do a quick data exploration. So if you have joined us from previous webinars, you probably will be familiar with this package that we're using called Pandas Profiling. It's a Python module that renders out a profile and a very quick exploratory analysis of your data set. So you have a fairly good idea of how your data set looks like just with a few lines of code. So from here, the first thing I already see is that I have about 881,000 data points, and then 5 different variables. I don't seem to have any missing data, so that's or any duplication rows. So as a data scientist coming in, that's also usually a good sign. And then I can also go ahead and then look into my different variables here. So I know that my timestamp it's unique, so that's also a good sign that my data is looking good. Now I'm looking into my actual variables of interest. So looking at casing pressure, get a distribution here, looks a bit right skewed. Seems like there's some extreme values on the higher end side here. I see that we have a mean and a median of around, just the mean of about 1,300 kilopascal here. Looking at my flow variable here, I see that there's a lot of zeros here, but for me, that seems like for the gas well data, because this is on a plunger, the zeros in the flow usually indicates that that's the shut-in time when the plunger is allowing it's down and the pressure is building up in the gas well to prepare for the next flow cycle. So the zeros here, that will make sense to me. However, later on, I'll have to also do a little bit more visualizations to make sure that these zeros are actually where they're supposed to be and not indicating of some errors in my data. But I do see that we do have a mean at around 12, 13 here, but that would be also including these zeros here. So then but looking at it, it actually seems like from the distribution that the flow, when it's actually flowing, is around 15. Similarly, I can look at my line pressure here, look at the distribution, look at my summary statistics, and also my CLDP. An interesting part of this package is it also provides a correlation, a quick correlation heat map that I can quickly look at and know what are different interactions between my variables. In this case, I'm very interested in just how the flow is correlated to all of the other variables. But from what I see, it seems like there's a little bit of negative correlations with all of the other variables, whereas but not very strong correlations, which seems a little bit surprising to me, because I know that the flow is actually on one hand should be highly correlated with my casing pressure. So this is one of the, I guess, the caveats of time series analysis is that a lot of these general data exploration that we do with other data science projects like machine learning is that these packages, they're not taking into account time. So then with time series, time is a very important variable. So this is why we'll actually need to do additional exploration and visualizations where we bring in time into the context and look at all these interactions. So next, I'm just going to run some graphs here. So in here, I'm just plotting out my 3 variables of interest. So my flow, my casing pressure, and my CLDP here. I'm just looking at it in a little bit more details from the package out there. So from what I can see is that my flow is actually, it really is around 15 dex when it's flowing. My casing pressure, I do have a lot of these tailing off, so it's the overall distribution is right skewed. And then my case line differential pressure here, though, after minusing the line pressure from the casing pressure, it does make the distribution less skewed and a little bit more symmetrical to work with. So with the next thing that I'm going to look at is I'm just going to zoom in on my time series here to around 10 days, and then look at how my 3 different variables is actually progressing over time and how they interact with each other. And so from here, what I can see is actually very distinguishedly on every single flow cycle here when the plunger goes up and goes down, allowing the casing pressure here to build up before it's being released, and then the flow comes in to flow for a certain period of time before the plunger goes back down and shut it in. So like from here, this visualization, I can see very clearly that my flow and the casing pressure is interacting correlated with each other quite well. In contrast though, the case 9 differential pressure, I can see the peaks there, but it's not that distinguishable. But in this case, this is still suggesting to me that my data that's being collected for this gas well, it's the casing pressure and my flow, they are operating properly. So this is just 10 days period, but I have a year worth of data from my gas well. So I wanted to be able to look on overall how it is operating over time. So I want to get the big picture in terms of how my gas well is doing. Looking at just a very simple 10 days window, that won't tell me much. So now I'm going to go ahead and create a plot to look at my entire data set. But what you're going to see here is that it becomes very, very busy. So then my flow data here, which is what I'm actually trying to get some insights out of, it's because of the minutes data and because it's a year worth of data, it becomes very busy. And because of the data, just the nature of the data of these frequent visits to the zeros because of the shut-in time, the data, it just makes the data look even more busy for us to really get any sort of trends or insights out of it. We are able to see some big dramatic events here in casing pressure. These might correlate with some of the maybe maintenance events or shutdown time that we have in the past, but overall, just looking at the flow here, we can't really tell much out of it. So now this is why we're going to bring out this whole demo here on the time series analysis, is that we're going to just apply some fairly simple, fairly common time series technique on our flow data here to see how we can take this very busy, very frequent clutter data and then get an insight or see the underlying trend and patterns underneath it. So then this is the purpose of the demo here that we're going to be focusing on. So I'm going to show you and introduce to you 3 very common time series techniques. So first is resampling, smoothing, and then decomposition. All 3 of them is going to produce very similar results, but they work slightly differently, and because they're all very common, so then we'll just do a quick comparison over them and then look at how they are able to generate the insights for us. So the first technique that I'm going to show you is resampling. So what resampling is that we're changing the frequency of our data. So this is a technique that's used very common to either upsample our data to make our data into higher frequency, so we're interpolating the data between the data points, or we're downsampling it so that we're getting a more summarized set of series that can represent our data better. So if you want to read a little bit more about resampling, there is a link that I posted here along with the notebook by Jason Brownie on a little bit more in-depth read on resampling and how resampling works on time series data. So what I did here is that I actually just used the pandas package to resample my data from minute frequency into day frequency. And then I'm aggregating it by using the average of the hour. So then looking at just the flow here that is plotted for this resampled series, in comparison to what we saw with that very busy clutter data, we can actually already be able to fairly straightforward distinguish this downward, almost look linear trend for our flow over time, which is expected. And we also see these big dips and dramatic events in terms of our flow. This probably correlates with past events, maybe the maintenance shut-in time where we're doing some different operations on the well. But with this, just the flow here, we're able to actually see the impacts of those events. And then we can better evaluate and access those events in terms of how they are affecting our flow and then on the performance of the gas well. So this is just a very simple, straightforward resampling of our data. And the other technique that can show us very similar insight is the smoothing. So smoothing usually uses a windowing technique where, again, we're defining a window width. That's usually how many data points we're looking at per window. And then we're smoothing over that window by calculating the average for it. And then we shift that window along the entire time series for that smoothing effect. If you want more information on moving average and windowing, there's also a link here down below in the tip section that also a blog by Jason Brownie that you can go in and read a little bit more about moving averages and smoothing. But in here, I'm just going to show you, I have windowed over increasing a window size so you can see the effects of the smoothing. So from 1 minute, which is our original frequency of the data, to a window size of 1 hour, half a day, 12 hours, 1 day, and then 1 week. So that as you can see from this graph here, so this is the original series of our flow data, and then applied a smoothing window of 1 hour over it. Seems a little bit, some of the zeros came out because of the averaging effect. And then this is a 1 day period. Oh, sorry, this is 12 hours, sorry. So a window of 12 hours, 1 day, and then finally 1 week. So then, like, after we've applied the window of 1 week events of being smoothed over, we see a very similar trend in terms of what we got from the resampling. There's a little bit more noise because of just the nature of how the moving averages work. But again, we see these four dramatic events here, and we see that downward trend. So just a quick tip and notes here. Sorry, moving averages, in this case, we're using it for smoothing, for data exploration and data preparation. But moving averages itself is a very big concept inside time series. It's also used in removing seasonality from our time series, and it's also used in actually making model for forecasting. So again, if you want to read more about moving averages, you can go into the link here by Jason Brownie where it goes into a little bit more in-depth in terms of all of the different ways that moving averages are used. So the last little bit here that I'm going to go into, I see we're a bit over time, is decomposition. So just going through the data here. We'll also come back and visit as our next section is also going to still be on this time series analysis here, where we're actually going to bring this use case into building a forecasting model. So we will also revisit this decomposition part as it is a very important concept for forecasting. But if you're able to stay a little bit more time here, I will go ahead and finish explaining this concept here. So in terms of time series, the very base analysis of it is made of 3 different components: a trend, a seasonality, and a residual. Trend is just how it looks over, is the overall pattern of it over time, whereas seasonality is just like for season is a cyclic pattern in our time series. Residuals is then that random effect in underlying that is not accounting into the trend, not inside the seasonality, but just the random effects. It might be noises or random processes behind your time series. And then it's also made out of 2 different equations where we say all of these, if all of these effects is an addition of each other to produce every single data point, is an additive time series, or if these 3 components are actually a product, and then it multiplies each other and then becomes your data point that you gathered from time series, then it's a multiplicative. The most significant part is the variance that changes over time in your multiplicative time series model. So when we talk about decomposition, it's just that we take our time series, we apply an algorithm to it so that we can decompose our time series into these 3 different components. So in this case here, just show quickly how it looks like with just a simple Python package. It has decomposed my flow data here into a trend, a seasonality, and a residual here. So then from here, this is usually the first step to a lot of time series analysis, where we actually just decompose our time series into these 3 components. We can see the trend, again, a very similar trend as the other techniques that we have applied. And then also again, these 4 big dramatic events here. Seems like actually there's another 1/5 here. But then like there's also decompose by default, it tries to fit a seasonal component to it. In this case, as a data scientist coming in, knowing my data, I might be a little bit more conservative in terms of how much season actually plays into my time series here. But the most important part for me is actually my residuals here. The residuals, it might not seem very obvious at this time, but it becomes very important in terms of later on when we do time series modeling and forecasting. So that actually brings us to the end of this notebook here. So then like what this notebook is showing is actually very similar to what we would do for data explorations in other data science projects, just getting some insights, knowing our data, knowing how that time series is, then trying to get into the trends and patterns underneath all of the noises that might actually clutter up the time series. So in our case here, the flow were the original data set because minutes frequency, frequent visits to the 0 points, it becomes very cluttered, very busy for us to generate any insight, and just doing some simple time series processing, we're already able to get the big picture in terms of how our flow in the gas well is performing over time. So then like from this analysis here, there's actually 2 ways in terms of like that I can build off another use case. Am I going to look at the impact of all of those dramatic events that I saw in the latter half of my time series, or I can go into the first half where things were relatively stable and try to model a forecasting model out of it. So the forecasting was something that we'll be continuing next section. So please stay in tune and then we'll be sending out invitations for that event as well. So with that, sorry, we're over time. I'll just bring that back to Babak. This marks the end of the notebook here.
Thank you, Sylvia. As usual, great job. So I hope that you enjoyed the process that we went through to generate some insight on the scaled gas well data. I apologize for going over time. This seems now to be a trend. Every time we have these sessions, we're a few minutes over. But thank you for staying with us. Please provide feedback through our community, join the platform, help us make this bigger and stronger in oil and gas. I look forward to see you in the next session where we take this and start to forecast the gas production of the well using forecasting techniques. Thank you, everyone. Stay safe and have a great day.